Newman projections are used to represent the different conformations that a molecule can undergo. On these sp3 hybridized carbons, they rotate along the different bonds. They're not static. They're always rotating constantly in a circle, going through different conformations. And the Newman projections are used to represent what conformation is happening. So here, these are tetrahedral shaped, like this. So when we look at it from this perspective, it looks like a triangular shape. So these bonds can be opposite of each other, like these two triangles, or they could be superimposed over each other, like this. So where these bonds on the carbons are in relation to each other is what the conformations are, and this is what the Newman projections are intended to represent. In the ethane molecule, which is this example, it's really not so important because the energies aren't so great and the molecules aren't very bulky, but in something like butane, just to use this as an example, this to show why someone would care about these conformations. If one were to ask which would probably be in lower energy, a butane conformation like this, or with this rotated 180 degrees. So we'll just draw a Newman projection. You can see there's a lot of interference here. So what is drawn right now is this. We'll use this one for the other one. Where these are superimposed on each other. These are going to be repelling each other. These are going to be repelling each other. And these are definitely going to be repelling each other because these are much bulkier. They are interfering with each other's space and repelling each other. So what is going to happen is that most of the time it's going to exist something like this. Where these two ends are maximizing the distance from each other, so there is as little steric interference as possible. Often, sometimes though, the opposite will occur. Say this is something that is a positive end and this is something that's a negative end. It might attract each other. That's often how rings are formed. You'll have these opposite ends that will bend themselves into a ring. But most of the time, they're going to be repelling each other, and they're going to spend more time in this conformation than in this conformation. They're still going to be rotating all the time, going through the different conformations. But if someone were to take the average butane molecule and have a look at it, most of the time they're going to find it in this conformation here, where the two methyl groups are on opposite sides of